We're next going to tackle a different kind of application that will require the use of a system of linear equations to solve. And we can describe this kind of problem as being a typical mixture problem. And the problem is this. We're told that a chemist has two different solutions of water and acid. One solution is 20% acid and the other is 45% acid. And he would like to make a mixture that will put those two solutions together, creating 3 liters of a solution that will be 28% acid. And we're asked to find how many liters of each of the 20% and 45% solutions he should use. So as we've done before, we're going to organize the information into what we know and what we don't know. And you can see that I've done that down here below in blue. And so we can state that one solution we know is 20% acid. The second solution is 45% acid. The mixture is 28% acid. And altogether, we would like the mixture to have a total of 3 liters. And so what it is we need to find out that we don't know would be the number of liters of the 20% solution and the number of liters of the 45% solution. Now we next need to represent each of the items in the unknown column using a different variable. And I've chosen to let x be the number of liters of the 20% solution and y the number of liters of the 45% solution. And as we've done in the past, I think it will be helpful if we organize the information into a chart. So I've created 3 rows here. The first row will represent information about the 20% solution. The second row, information about the 45% solution. And the third row, information about the mixture. So in the first column, which is the quantity, we can, I think, clearly put x is the number of liters of the 20% solution, y is the number of liters of the 45% solution, and we're told, you recall, that the number of liters in the mixture is 3 liters. Now for the next column, I've simply stated what the percent of acid in each of these solutions is, but represented in decimal form, because we'll need the percent in decimal form when we write the system of equations shortly. So 20% as a decimal is 0.20, 45% as a decimal is 0.45, and 28% as a decimal is 0.28. Now for the third column, hopefully this will seem reasonable. If you were to take the quantity or the number of liters of the first solution, which is x, multiply by the percentage as a decimal of acid in that particular solution, that this product here then will represent the quantity or the number of liters of acid in that first solution. And in a similar way, the quantity or the number of liters of acid in the second solution will be 0.45 times y. And in the mixture, 0.28 times 3 will be the number of liters or quantity of acid in the mixture. Now we'll use the first and the third columns here to write the system of equations we need to solve the problem. So hopefully it's pretty clear that we could write then that x plus y is equal to 3. The number of liters of the 20% solution added to the number of liters of the 45% solution is equal to the number of liters in the mixture. And from the third column we can then write 0.20x plus 0.45y is equal to 0.28 then times 3. And so the second equation is saying to us that the number of liters of acid in the first solution added to the number of liters of acid in the second solution is equal to the number of liters of acid in the third solution. So we'll next then tackle solving this system. Now to solve the system of equations that we've created, I think the best first step here would be to eliminate the decimals in the second equation. It'll make life a little bit easier and there'll be less chance for error, I think, if we do that. So to accomplish that, all we need to do is to multiply every term in the equation then by 100. And so that will produce for us then, well, the first equation will stay the same, so that'd be x plus y then is equal to 3. And then the second equation turns into 20x plus 45y is equal then to 28 times 3. And so if we simplify a bit more on the right hand side there, we'll have 20x then plus 45y is equal to 84. Now I think it probably will be easiest if we use the substitution method here to solve. So what I'm going to do is to solve the first equation here for y. So y will be equal to 3 minus x. And then we'll substitute that into the second equation for y. So what we'll then have will be 20x plus 45 times the quantity 3 minus x is equal to 84. And then 20x plus 135 minus 45x is equal to 84. And if we combine the x terms together, that will produce negative 25x. And if we subtract 135 from each side, we'll then have negative 51 on the other side. And dividing each side by negative 25, we have negative 51 over negative 25, or 51 over 25. And in this context, we definitely want to change that to a mixed number, so that would be then 2 and 1/25. And so y then will be equal to, if we go back to the equation we created above, which is 3 minus x, so it'll be 3 minus 2 and 1/25. So this will turn in to then 24 over 25. So we'll next then write a sentence answering the question posed by the problem. Now we'll next write a sentence answering the question that was posed by the problem, and we can state then that the chemist needs 2 and 1/25 liters of the 20% solution and 24/25 liters of the 45% solution. Then as our final step, let's check those values back in both of the original equations. And the first equation in our system, you recall, was x plus y equals 3. Substituting the value for x and the value for y, and adding those together, we can clearly see that the left-hand side will simplify to 3. And then the second equation in our system in its original form was this. The 0.20x plus 0.45y is equal to 0.28 times 3. And so what we'll first do is substitute the value for x here as an improper fraction and the value for y. And multiplying further, the first term becomes 10.2 over 25, and the second term 10.8 over 25, which will simplify to 21 over 25 and converted to decimal form is 0.84. So we can see that both of these values check in both equations.